Welcome to this course on Elements of Mechanical Engineering. So this is a course offered for aeronautical and civil engineering students in BTech course. And my name is D. Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. And the topic for today is application of robots in assembly and inspection. In the previous lectures, we have seen what are the robots, what are the different parts of a robot, what are the applications of robot in different material handling and other machine loading or unloading processes. In this lecture, we are going to see what are the applications of robots in assembly and inspection and how the robots are incorporated for doing these operations. We'll see in this lecture. First thing is, there are some processing operations where the robots are being used. So, mostly the robots are industrial robots which we are studying. These robots will have a robotic arm. The robotic arm is fitted with some kind of attachment called end effector. This end effector may be two types. One is a tool or a gripper. There are two types of your end effectors can be attached to any robot which are used in industry. So these end effectors will work in the required manner. We can replace the end effector and we can change the robot for a different operation. We can use the robot for another processing operation. Now we'll see what are the different processing operations a robot can be used in industries. The first one is, let us see what are the processing operations and how robots are used. So in this process, the robots perform an operation on a work part. So whenever we are working on a machining lab, when we are working for manufacturing a metal part, we can use robots for doing different works. Like we can incorporate the robots for removing the metal part from the casting. We know casting is a very process which includes a lot of temperature. When we want to design or we want to prepare an object in our required shape, we have to melt the metal up to a temperature where it forms into liquid. So the molten metal has to be poured carefully into the sand cavity. This cavity is called mold. So after solidification, the molten metal will take the exact shape of the cavity. Now this entire process is called casting. So pouring the molten metal and getting it to required shape is called casting. So in casting, what happens is, because the temperature of the molten metal is very high, human beings cannot work near a casting equipment. They can work, but they cannot work for longer period of times. So that is why robots can be incorporated for this purpose, because not only heat, harmful gases will be emitting from the molten metal, because molten metals, mostly they are of ferrous family. So the iron elements will evolve. They will generate some kind of carbon related gases, and they are very harmful for human beings. So that is why we have replaced the robots for doing the operations like casting. And after casting, we will do some other processes like forging or machining, welding, painting. All these operations can be done with the help of a robot. Now we'll see in this, for doing all these operations, a special end effector has to be attached to the robot for doing a particular operation. Different operations will need different tools or different type of grippers. To perform the process, the robot must manipulate the tool related to the part during the work cycle. So, if I want to use the robot for doing a particular welding, the robot has to manipulate its body on its own in order to align itself properly to do the process. So this is how robots are incorporated in the manufacturing units. So we can see there are three pictures in this slide. First one showing that the robot is doing arc welding. What is arc welding? Arc welding is the welding process which uses electricity and it uses resistance of the workpiece and air for generating large amount of heat in a very small place. So local heating of the metal will causes generation of a spark. So the resistance of the workpiece and the air between the workpiece and the electrode will generate the spark, and this spark will in turn heats the plate, and it will melt the molten flux, or the electrode will be melted, and this electrode will be formed as a layer on the workpiece. So this is how welding is done. And then in the second picture we can see the robots are being used for painting the car body. You can see in automobile assembly lines where number of cars will be produced in a single day, where we have to paint each and every car with precision and in less time. Because in assembly line, the different cars which are being manufactured will be moving from one place to another place. Like they will go on moving on the assembly line, like ramp. They will walk on the ramp. So the robot has to work precisely, and they have to work fast in order to create more number of products in less time. So instead of humans, robots are being used because the humans will take more time, and they may not do precisely, and moreover human beings required breaks, and they will take more time compared to a robot. So that is where robots are incorporated. And so a spray paint equipment is attached to the robot in this manner. And the third figure shows that the robot is being used for a machining operation. It is doing some kind of machining operation on a wooden piece, or it is a ceramic piece. So we can do different operations like machining, drilling, milling, etc. using a robot by attaching some kind of tool to it. So in all these three applications, we have three different types of tools attached to the end effector of the robot. In the first case, we have attached a welding electrode or welding torch. In the second case, we have attached a spray nozzle which sprays paint. In the third case, we have attached a drilling machine to the robot. So for doing different operations, we will use different types of tools. And this is another kind of tool which is attached to robot for doing other welding called resistance welding. Here this process is called resistance welding because of the resistance between the electrodes and the workpiece. The heat will be generated. So this welding method uses two copper based electrodes which are movable. I mean, one of the electrode is fixed and other is movable. Whenever these two electrodes are kept over a metal piece. So this kind of welding is mostly suitable for very thin sheets of metal. So thin sheets of metal, when we want to join, if there are two thin sheets of metal like this, I will place one sheet on the other and I will make the welding on the joint. So for getting this kind of spots, or we'll weld the two plates in the form of dots. So for getting this, we will use electrodes, and these electrodes will make the electricity flow through the workpiece, and due to the resistance of the workpiece, a large amount of heat is generated. So when we compare any metal with copper, see here these two electrodes are made up of copper. The copper is a very good conductor of electricity, and whatever the plate, mostly we will do this kind of welding for galvanized iron sheets. So iron is comparatively more resistive for electricity. That is why when electricity is made to flow through the metal workpieces, the heat is generated locally. So this heat is applied along with the little pressure of the electrodes. The two plates will be joined together. So thin metals are joined with the help of these two copper based electrodes, and a large amount of electricity is passed into the plates, which heats the plates locally to make a joint. So there are some conventional spot welding machines. These are very heavy. They will contain same procedure. They will contain two electrodes which are to be operated with leg. The lever should be operated with the leg for getting the welding spot. So we have replaced this with a robotic spot welding machine where everything is very simplified, and the pressure being applied is also done by the robot itself by using a actuator for that particular purpose. So, because why do we need this complex machine? Why we have simplified this complex conventional spot welding machine is that it needs examples of places where we use spot welding robots are car body manufacturing. If we want to weld very thin layers of car body, which are made up of sheets, if we want to make these spot welds on the car body, we have this conventional machine where we have to take each part and we have to keep it in the machine, and we have to apply pressure. So large body parts require large spot welding machine. That is why we have replaced the conventional machine with robotic spot welding machine, where the robot itself aligns along the body of the car and it can make welds on the surface. There is no need to align the car body according to the machine or the spot welding machine. The robotic spot welding machine itself aligns with the car body and it can make some joints on the body. So this is one application of robots in car body manufacturing, where we will use a spot welding machine attached to the robot. And the second one is continuous arc welding, where we will use a normal electric arc welding with the help of a robot. So the robots are attached with electric electrodes, where they are consumable. The consumable electrodes are attached. So these electrodes, they can do welding for any bodies. Why we have developed this continuous arc welding robots? Because we know the robots can work precisely and they can work in less time. So for doing a welding which requires more time or more precision by a human being, it may take very less time for a robot to do the same work. So see here, it is used to provide continuous welds which results in a joint formed which is stronger than one formed in the spot welding. So this kind of welding machines can give a stronger joints when compared to spot welding machines, because spot welding machine is one which is used for very thin sheets of iron. Very thin sheets like GI sheets can be welded in spot welding. Coming to this welding, we can weld very thicker plates, and also we can get very stronger joint when compared to spot welding. So we all know how welding is done. Welding process requires a consumable electrode and two workpieces, and there should be a completion in the circuit. So whenever we touch the workpiece with a consumable electrode which is connected to the electrical transformer, it produces some kind of a spark. When it is moved little closer away from the workpiece, the electrode should be moved away from the workpiece so that the air resistance will create a spark. Now this spark is used to heat the workpiece and the welding is done. The operating conditions of this welding process is very harmful for operators. So the temperatures are very high when we are welding. The temperatures locally goes up to 1200 degrees centigrade, where the metal will melt slightly. So this kind of high temperatures are not suitable. And second thing is, the spark which is being generated while doing the welding is very harmful for human eyes. You cannot see that with the naked eye. That is why the robots are being used. Suppose if I want to do arc welding, I have to wear a shield, or I have to wear a dark visor. So the disadvantage of a dark visor is, first thing, it will be in the form of a helmet where it causes very discomfort to the operator. And second thing is, the visor is so dark that without an electric arc, we cannot see through the sheet. We cannot see through the visor. Whenever there is a spark, we can see clearly through the visor. When there is no spark, we cannot see where the workpiece is or where the electrode is, where we are doing the welding. So this causes a little trouble while creating a precise joints, because the welder cannot see. He has to carefully place the electrode where he want to do, and after that he has to close the visor on his face. Then he has to do the welding. Whenever he start the welding, he can see through the visor clearly. But during this process, there is a chance of misplacing the electrode at the correct point, because while he wearing the black visor, dark visor, he may misses the spot where he has to do the welding. That is why the this is another kind of a disadvantage of human beings using arc welding. So arc welding machine are now automated by robots. Robots can do this arc welding throughout the day without taking any breaks, and they are used for welding the metal parts precisely and in less time. They don't need any breaks. And robots replace humans in this process, because robots are more efficient and they can do the welding in very less time when compared to human beings, and they don't need any security or dark visor. They don't need any surrounding temperature control system. So that is why robots are being used for this process. Okay, so continuous arc welding robots are another robots of where they are used in industries. And then this is spray coating. So in this picture, we can see a robot is attached with a nozzle which sprays paint on automobile parts or any bodies. Here we can see all the body parts are placed in a row and they are being painted. All parts are very similar to each other. So painting is done on each body with precision and in less time. Okay. So we know the cost of robots and installation of the robots is very high. It is very costly. But once they are installed, they can be working round the clock. So it uses a spray gun which is directed at the object to be coated, and a fluid flows through the nozzle at a high speed and dispersed over the objects to be painted. So what are the spray paint that is coming out of the nozzle? That is made to fall on the object which is to be painted. Now what happens is, if we want to paint, like if a operator has to paint the object, he will take more time, and moreover he may not give a uniform coat on the body, because he will be using his hands which are not precise, so the painting on the body may not be uniform. So robots can paint the body very uniformly because they are coded. They can move from one place to another place in a precise path which is predefined in the code. So that is why spray painting using the robots is very useful in industries where we can get very uniform coat in less time. So fluid flowing through the nozzle which is coming out at a very high speed is painted on the object. Now this process is harmful to human beings. How this process is harmful? Because the spray is painting at a very high speed, at a very dispersed level. Very small droplets of paint will be coming out of this nozzle. So that is why when humans are working for painting the car bodies using a spray nozzle, so these droplets can get into nostrils, and from there it can goes into the lungs, and it may cause some kind of damage to the lungs. So that is why the robots are used. So this is one another important problem which makes the use of robots for painting, because the robots, they don't inhale or exhale anything. Human beings are very prone to lung diseases when they inhale this kind of paints, because they are all chemicals. And using robots for painting will increase the uniformity of the painting and takes less time. This is another disadvantage. This is advantage of the robots, where they can create uniform paints in less time. And some applications of using the spray coating robots is automobile car bodies, engines, wooden and porcelain products. So automobile are mostly cars and trucks, and engines are like the engines we use inside the car body. We'll paint them sometimes. Mostly they are all made up of aluminum. So the wooden parts also can be painted with the help of a robotic painter. And porcelain products, which are dining sets, these are also painted with the help of spraying robots, spray coating robots, where the porcelain products are nothing but the ceramic products, which are used for many applications in dining and tiles. So other applications of robots are, there are some applications where the robots are being used. Like in the first picture, we can see the robot is being used for doing the process drilling. So a drill bit is attached to the robotic end, where it can be rotated and can be precisely made holes on workpieces. So this is one application. And the second application is the robot is being used for cutting the metal sheets or metal plates with the help of laser. A laser beam is attached to the end effector of the robot, where it can be moved from one point to another point, or it can make circular cuts very easily. A human cannot make a circular cuts with his hand. So that is why this programmable robot, it can make any definite shapes which are required for complex body designs, like circular shape, curved shapes, or any kind of shapes. They can be done easily with the help of a robot. So this is laser cutting using a robot, and this is water jet cutting. So water jet cutting is a process where water and some kind of abrasive particles are joined together, and that mixture is used for cutting metals. Now we will get a doubt how the water is so hard enough to make cuts on the metal. Not only the water when it is mixed with some kind of corrosive abrasive particle, and it can create, when the water and corrosive abrasive particles are combined together, and this mixture is made to flow through the nozzle at very high pressure. This pressured water coming out of the nozzle can make cuts due to the friction created by the abrasive particles in the water. So when this mixture is coming out of the nozzle at very high speed, it will make the metal very frictious, and due to this friction between the water jet and the metal will be cutted instantly like a cake. So these are some of the applications where robots can be used, where they can be used for operations like drilling or some other machining processes, and grinding process, grinding, wire brushing, and similar operations. So grinding the machine tools or grinding the surfaces for getting smooth finish. So we can use the robots by attaching a grinding wheel to the end effector. And then for water cutting, laser cutting, and for riveting also, we can use robots. We can use two electrodes, or we can use two jaws of the robot for fitting the rivets to metal sheets. So these are some of the applications of robots in processing operations. So changing the different kind of tool and changing the program according to our design, we can use the robots, or we can use the same robot for multiple applications. Now let us see what is the applications of robots in assembly. So in mechanical engineering, we mostly deal with different components of a body where they are prepared or manufactured separately, and they has to be bring together and they have to be assembled. Now, whenever we want to do a big assembly, we don't need robots. Human beings can do that manually because of the hugeness of the body. Because when we want to assemble a truck, we can do it with the help of some robots and mostly humans. Okay. Now, any small applications or assembling small mechanical parts, we need robots because they can do that work precisely without getting any tiredness. So that is why the robots are being used in assembly of two or more parts to form a new entity called assembly. Okay, the new entity which is obtained after joining two parts is called an assembly. So assembling operation is a labor intensive activity. So if we have a human being who is working for 8 hours a day, and if he know how to assemble things, he will charge more when compared to a person who do the machining process. Okay, so lot of labor is required for doing a small assembly also. That is why the assembly process is now being done by robots, because robots can work all the day without taking any break. So they're also highly repetitive and boring, because most of the assembling processes are repetitive. When the task is repetitive or boring, a human operators may get tired easily, and they may not do the work precisely because they are doing the same kind of work repeatedly. Precision is lost. So that is why we are replacing robots. So the robots have the disadvantages of working at high speed. Here, one disadvantage is there for using the robots, because if we want to use the robot for a particular application like assembling the machine parts, so the robots generally work at high speed, so we have to slow down the process. So we have to modify the programming of the robot in such a manner it creates or it works at a slower level than its normal operational speed. So that is one disadvantage which can be modified or which can be overcome by changing the program of the robot. Now some of the examples where the robots can be used is in the kind of assembly. So assembling of pens, when we are using normal pens for writing. So different parts of the pen can be easily assembled with the help of robot, because they are very small. Human beings may get tired because of the boring repetitive task. So that is where we can use robots. And then mechanical pencil, which uses a lead pencils will be there. So these pencils are also can be assembled with the help of robots. Okay. So, and garden hose nozzles. So these are another small kind of devices which are attached to the water pipe. They can be used for gardening the watering the garden. So this kind of nozzles can also be fitted or assembled with the help of robots. So the robots are widely used in many applications, and one application is assembling of mechanical parts. Now we'll go to the next slide. So the robots can be used for inspection as well. So whenever there is a robot, we can use that robot for inspecting whether the objects has been manufactured correctly or not. So when we have a machine part, the robot can be used to diagnose or check whether all the machine parts are assembled properly or not. Okay. After assembly, we have a robot for assembling the machine part. After that, we can use that machine whether it is properly assembled or not. We can use different kinds of sensors on the robot to check whether the body is correctly assembled or not. So in this process, we can use different kinds of sensors like pressure sensor, vision sensor, infrared sensor, etc. These are some of the sensors where these are very useful while inspecting the body. So here we'll take an example of the Coca-Cola manufacturing unit, where a large number of bottles will be manufactured. They are being manufactured using a technique called blow molding, where a small amount of glass is taken and it is heated, and hot air is passed into the small part like a test tube. This will be blown into the shape of the Coca-Cola water bottle, and after that, the bottle is filled with the drink. Then after that, the bottle is to be fitted with the cap, and after that, the body, it is labeled with a sticker. So all these operations are done automatically, because a production unit has to develop like 1,000 bottles in an hour. So precision is required. Inspection is also required. So that is when the robots are used. When a large number of bottles are coming in a assembly line, they are moving very fastly. Okay, so they has to be inspected whether they are precisely made or not. Like there are, suppose I am taking the examples of three processes: filling the bottle, putting the cap on the bottle, and third one is labeling the bottle. So these are the three operations I need to do on the assembly of a Coca-Cola manufacturing bottle company. Now we'll see these are the different operations: filling the bottle, screwing the cap, and labeling the bottle in order to finish the product. Now what happens is we can place a sensor. This sensor can sense when the bottles are moving on the conveyor line. The sensor can sense immediately by using an infrared whether the bottle is fitted with a cap or not. If it is not fitted with a cap by any mistake of the previous machine, so this bottle can be removed from the conveyor line, and it will be sent back again to repeat the process. And then after this process, we can check whether the bottle is filled or not. We can check whether the cap is fitted to the bottle or not, and we can check whether the label is sticked on the body surface. So these are all the processes which can be automated. So all these processes will require some kind of sensors. They mostly use infrared sensor for this process, where they will easily identify whether the particular object is placed on the bottle or not. And this is done at a very high speed compared to human beings, because the conveyor lines are moving very fastly, like 1 meter for every second. They will be moving that fast. So human beings, when they want to inspect the bottles on their own, they cannot do that much fast. So that is why robots are very capable of inspecting the elements. So this is one example where we can use robots for inspection. So lot of other applications are also there where robots can be used for checking the assembly of the machine parts, like car body or any truck body. We can use the robots for inspection of the entire body. So these are some of the applications where robots can be used for assembly, inspection, and some other processes like welding, painting, and water jet cutting, etc. So far we have seen what are the different processing operations where the robots can be applied or used. So they are welding operation where we can use robots, or painting, cutting, like machining operations can be done with the help of robots, and assembly operations, like we can use robots for assembling multiple parts of a machine, and inspection of mechanical parts. After assembly, we have to inspect these mechanical parts, whether they are assembled properly or not. So these are some of the applications of robots in industry, where they can be used for these processing operations, assembly, and inspection. So that is all for today's lecture. We'll meet in the next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.